The concrete slump test is an empirical test that measures the workability of fresh concrete. More specifically, it measures the consistency of the concrete in that specific batch. This test is performed to check the consistency of freshly made concrete. Consistency is a term very closely related to workability. It is a term which describes the state of fresh concrete. It refers to the ease with which the concrete flows. It is used to indicate the degree of wetness. Workability of concrete is mainly affected by consistency, that is, wetter mixes will be more workable than drier mixes, but concrete of the same consistency may vary in workability. It is also used to determine consistency between individual batches. The test is popular due to the simplicity of apparatus used and simple procedure. Unfortunately, the simplicity of the test often allows a wide variability in the manner that the test is performed. The slump test is used to ensure uniformity for different batches of similar concrete under field conditions, and to ascertain the effects of plasticizers on their introduction. In India, this test is conducted as per a specification. Principle: the slump test result is a slump of the behavior of a compacted inverted cone of concrete under the action of gravity. It measures the consistency or the wetness of concrete. Apparatus: metal mold, in the shape of the frustum of a cone, open at both ends, and provided with the handle, top internal diameter 4 in, and bottom internal diameter 8 in with a height of 1 foot. A 2 feet long bullet-nosed metal rod, 5/8 in diameter. Procedure: the test is carried out using a mold known as a slump cone or Abrams cone. The cone is placed on a hard non-absorbent surface. This cone is filled with fresh concrete in 3 stages, each time it is tamped using a rod of standard dimensions. At the end of the 3rd stage, concrete is struck off flush to the top of the mold. The mold is carefully lifted vertically upwards, so as not to disturb the concrete cone. Concrete subsides. This subsidence is termed as slump, and is measured into the nearest 5 mm if the slump is less than 100 mm and measured to the nearest 10 mm if the slump is greater than 100 mm. Interpretation of results: the slumped concrete takes various shapes, and according to the profile of slumped concrete, the slump is termed as true slump, shear slump or collapse slump. If a shear or collapse slump is achieved, a fresh sample should be taken and the test repeated. A collapse slump is an indication of too wet a mix. Only a true slump is of any use in the test. A collapse slump will generally mean that the mix is too wet or that it is a high workability mix, for which slump test is not appropriate. Very dry mixes. Having slump 0-25 ohm are used in road making, low workability mixes. Having slump 10-40 ohm are used for foundations with light reinforcement, medium workability mixes. 50-90 for normal reinforced concrete placed with vibration, high workability concrete. 100 ohm. European classes of slump: according to European Standard EN 206-1 2005, classes of slump have been designated, as tabulated below. Limitations of the slump test: the slump test is suitable for slumps of medium to high workability, slump in the range of 5-260 ohm. The test fails to determine the difference in workability in stiff mixes which have zero slump, or for wet mixes that give a collapse slump. It is limited to concrete formed of aggregates of less than 38 ohm. Differences in standards: the slump test is referred to in several testing and building codes, with minor differences in the details of performing the test. United States: in the United States, engineers use the ASTM standards and AASHTO specifications when referring to the concrete slump test. The American standards explicitly state that the slump cone should have a height of 12 inch, a bottom diameter of 8 inch and an upper diameter of 4 inch. The ASTM standards also state in the procedure that when the cone is removed, it should be lifted up vertically, without any rotational movement at all. The concrete slump test is known as standard test method for slump of hydraulic cement concrete, and carries the code OR. United Kingdom and mainland Europe: in the United Kingdom, the standards specify a slump cone height of 300 ohm, a bottom diameter of 200 ohm and a top diameter of 100 ohm. The British standards do not explicitly specify that the cone should only be lifted vertically. The slump test in the British standards was first and is now replaced by the European standard. The test should be carried out by filling the slump cone in 3 equal layers with the mixture being tamped down 25 times for each layer. Other tests. There are many tests for evaluating slump in concrete. One example is the K-slump test. Other tests evaluating consistency are the British compacting factor test, the VEB consistometer for roller compacted concrete, and the flow table test. Another way of determining slump is to use an automated slump meter. Sensors and controls enable the meters to measure and display slump. Their reliability has by now earned them acceptance in various standard codes such as ASTM International. Some automated slump meters, such as the one by Vrivi, also can add water to the concrete mix in the delivery truck while in transit. In 2013 ASTM C94 per carat 94M was revised to allow water additions during transit for trucks equipped with automated slump monitoring and measurement systems. See also, plasticity, flow table test, references, ABCDEF Gampier, ML Concrete Technology. Tater McGraw-Hill. Retrieved December 11, 2010. W. B. McKay. J. M. McKay. Building Construction Vol. E. Orient Longman Private Limited. PA 32. ISBN A978-81-250-0941-2. Retrieved June 9, 2012. ABCDE Slump Test. The Concrete Society. Retrieved December 11, 2010. A. B. Leon, Arthur. Materials for Architects and Builders. Butterworth Heinemann. Retrieved December 11, 2010. Tattersall, G. H. Workability and Quality Control of Concrete. London, E. and F. Enspin. ISBN A0-419-14860-4, qpa.org. QPA-BRMCA Committee Bulletin 3, ASTM Complete Set 2013 ISBN 9781622042715, CSNEN 12350-4, Testing Fresh Concrete, Part 4, Degree of Compactability, ASTM C1170 per carat 1170M October 8, 2008 Standard Test Method for Determining Consistency and Density of Roller Compacted Concrete Using a Vibrating Table, Panarese, William C. Kuzmitka, Stephen H. Kirchhoff, Beatrix. Design and Control of Concrete Mixtures. Skokie, Illinois Portland Cement Association. ISBN A0-89312-217-3A.